Good morning. It's great to see everybody. I'm honored to be here. Thanks to Marcia, Doug, and Pam for inviting me. And today I'm going to talk about, I'm a professor at University of Delaware, and I'm going to be talking about how Lynn shaped my research on math learning disabilities. So how I got to know Lynn really was through NICHD, many NICHD PI meetings where we were often sitting together and kind of supporting each other. It was really nice. IES review panels, when we were on panels with people with very divergent opinions, saying things like, oh, math disabilities don't exist. And so we kind of look at each other. And then we collaborated on the Center for Improving Learning of Fractions, funded by Nixer at IES. And then subsequently numerous advisory panels, and we were worked together on the IES practice guide on math interventions. On a personal note, Lynn was amazingly supportive, exceptionally generous as a co-PI and an author, extremely efficient. She puts everybody to shame, and she made collaborating with other people moving forward disappointing because she was never late, and I loved it. It was so efficient, and she was a colleague and friend who honestly made me better. So today I'm going to talk about my collaboration with Lynn on our IES-funded Center on Improving Learning of Fractions. Then I'll talk about the practice guide that we worked on together, and then my own intervention work, which was heavily influenced by Lynn. So just to get started, a survey of 1,000 Algebra 1 teachers report fractions to be a top barrier. One teacher said, when they come to middle school, there is a dominant idea that a fraction is two different whole numbers written in some weird format that indicates a relationship. So fractions are hard for everybody, and especially children with learning difficulties. So we got this idea. IES put out an RFA for a center on math learning difficulties, and Lynn and I had both been working in the whole number space with younger children. That's how I got to know her, through the NICHD grants, and I thought, oh, I would love to tackle fractions because, we're starting to learn theoretically more about fractions, but not much had been written in that area. So I asked Lynn if she was interested in collaborating, and thankfully she was. And we put together this amazing fractions center that had 3 strands. The first was cognitive processes and math learning, which was led by cognitive psychologist Bob Siegler. He had really been doing very interesting theoretical work in this space, so we were so excited that he agreed to work with us. On my strand, I looked at predictors of math, of difficulties with fractions through longitudinal studies. And then Lynn's strand was intervention development. So the strands were very synergistic. And then Russell Gerson was the PI on the leadership strand that was involved in outreach and dissemination. And sometimes you think of centers as kind of being like they're big, they're bloated, they end up by not being kind of disappointing. But I just felt like this one was amazing, and I feel like we did, many thanks to Lynn, really, I think, impact the field a lot. So our core center activities were, although the strands approached the study of fractions from a different vantage point, they shared a common perspective, and that is the number line. And Bob had done a lot of theoretical papers on the number line, which we hypothesized is an important but overlooked instructional tool with which students can build understanding of fractions, and that it can be an effective assessment tool to determine student progress over time. So we started out thinking, why are fractions hard for so many students, and especially students who are struggling in math? Well, numbers of the same magnitude can look very different. Unlike whole numbers, 3/4 is the same as 9/12, And sometimes when numbers get bigger, the fraction gets smaller. And so this can lead into a whole number bias where students think 1/8 is bigger than 1/4 because 8 is bigger than 4. But of course, that isn't always the case. And there's an infinite amount of numbers between two fractions, and related to all of these issues, the number line is an effective tool for addressing them. So I'm going to first present some interesting findings from the longitudinal strand that was conducted in Delaware. And we had 536 students that were first recruited in 3rd grade. And the students were drawn from 9 elementary schools in 2 public school districts. And starting in 4th grade, this kind of converged with our grant. The curriculum was aligned to the Common Core state standards in math. And we did have a very diverse sample. In all of our all 3 strands, we did oversample for at-risk students because we wanted to make sure that they had representation in the study. So this particular finding, yeah, there we go. We found very interesting because here you can see that many students show little growth in fraction magnitude understanding between 4th and 5th grade. And if you look on the vertical axis, that is performance on the number line estimation task, estimating fractions on a number line. And basically the lower the score, the better, because you're more accurate, so you have a lower score. And on the horizontal axis is the testing periods. And you can see that in the red, that's class 1, there were a number of students who started out very accurate and they ended accurate. And then there's the typical trajectory in class 2, which is the blue one, where they started inaccurate, but by the 6th grade, they became quite accurate. But then there's this concerning class 3 that starts out accurate in winter of 4th grade and makes literally no progress or very little progress across the period. And then here you can see a little bit more of the 3 classes. I guess it's probably easier to see on the side monitors, but I'm just kind of in awe of the class 1 students. You can see how accurate they are. The closer they map around the line means the more accurate on the various fractions. But you can also see that class 3 is pretty much all over the map with their estimations, and they tend to estimate most fractions, even though this is a 0 to 2 number line, they estimate most fractions as being less than 1. So they think of fractions as being very small numbers. So this really kind of piqued our interest. And here you can also see that accuracy on number line estimation is very associated with how children are going to do in math achievement more generally. The class 1 students, 68% of them were scored advanced in math in 6th grade. Class 2, they were pretty good too. They at least 64% met the standard and 19% were advanced. But then that class 3, the children who showed very little growth, 35% of them performed well below standards. So you can see this poor number magnitude estimation is a concern overall for these kids in their math achievement moving forward. So, and then like at the same time, Lynn was doing innovative intervention development. And her intervention, which Marcia touched on a little bit earlier this morning, focused on fraction understanding, and within fraction understanding, on fractions magnitude understanding using a number line. And the business as usual condition focused comparatively on fraction understanding and procedures, and within fraction understanding, mainly on part whole understandings. And amazingly, she did 5 randomized controlled trials, 1 each year, with 4th graders with math difficulties. So while I was doing the longitudinal work, she was doing the intervention, and Bob was doing the short-term experimental studies. So one key Fuchs finding was each year of the 4th grade intervention, improvement in magnitude understanding, but not improvement in whole number or part whole understanding, mediated the effects of the intervention versus the business as usual on the fraction achievement outcome. And these data support the National Math Advisory Panel hypothesis that improvement in magnitude understanding is a key mechanism explaining fraction learning, and its recommendation that fraction instruction be reoriented in this direction. So, Lynn, we did a special issue on the Fraction Center in the Journal of Learning Disability, and here is a quote from Lynn. She writes, in sum, these 5 RCTs document the efficacy of the small group intervention we developed, guided by explicit instructional principles and relying on fractions magnitude understanding. We iteratively developed and tested the effects of a core program, even as we isolated effects of a series of intervention components. Result of the component analysis indicated added value for speeded strategic practice when students have sufficient working memory capacity to engage productively in such practice. They revealed strong added value for multiplicative reasoning, word problem component, and a supported self-explaining module. At the same time, our intervention only addresses 4th grade fraction standard. Research is sorely needed to address the challenges associated with multiplying and dividing fractions, as well as other complex math curricular targets. So that kind of led to some research that I continued in my lab post the Fraction Center Development Project. And I got very interested in intervention kind of in the last year of the Math Center, because I'd learned so much from Lynn, and I had sort of dabbled in intervention with early number sense area, but wanted to do some of this with fractions too, because I was just so stunned that there's so many children that make so little progress in fractions, and they end up in 6th grade learning in the gen ed curriculum, but they don't even really understand much about fraction magnitude. So we were lucky enough in my team with co-PI Nancy Dyson to get a development grant from IES to develop a fraction sense intervention. And here we worked with 6th grade because Lynn was working in the 4th grade space, and that's important because you want to catch kids early. But the reality is there's still many children in 6th grade that fall through the cracks that need continued support to build those fraction foundations. So the goal of our fraction sense intervention was to develop an effective intervention to help struggling students make sense of fractions, and ground the intervention into evidence-informed practices related to how children learn. And then this was like a priority of IES, is to develop a usable intervention for classroom teachers or school interventionists in multi-tiered settings. So they didn't want us to do an intervention that was carried out by researchers. Ultimately, they wanted something that teachers could easily implement. So in the first year of the project, we did develop the intervention, and we tested it with researcher instructors, got good results. But as we worked in schools, we realized that the typical intervention teacher, they don't have 3 or 4 students. In some of the middle school interventions, there were up to 15 students. And so it really isn't practical to have like all these little activities and kids working, like 1 to 3 teacher-student ratio. So, we got this idea of, carrying out the intervention using animated PowerPoint slides so we could teach, the teacher could teach the intervention with larger groups. So we sort of moved forward in that direction and piloted that and got very good results. We were able to get reasonably effective results with larger groups in the middle school intervention setting. So that then led to an IES-funded efficacy grant where we tested the efficacy of this intervention carried out by teachers in sometimes relatively large groups and grounded in the principles from the science of learning, because all of us were continuing to learn about that during the development grant, and actually like Bethany Riddle-Johnson, who's here, she was one of our consultants and had written a lot about learning principles that we wanted to incorporate into our intervention. So here we evaluated the efficacy, we just finished this, of the fraction sense intervention, which was designed for 6th graders who are very low performing in math, at least 2 years below grade level on the school administered tests. And we didn't exclude any children from the sample. The FSI emphasizes foundational fractions, using number lines. We incorporate the validated principles for students with math difficulties, and again, it was a much harder study because teachers implemented the intervention. So also, a little bit before this, around the same time, IES and the What Works Clearinghouse published a practice guide that Lynn led, which was assisting students struggling with math, intervention in the elementary schools. I was on that panel too, but Lynn had and Robin, I see other people involved in this, Lynn was a strong leader on this panel, and the recommendations were based on rigorous review of studies. And so we aligned our FSI very closely with the recommendations provided in this guide. And so this is just a summary of the recommendations from the practice guide that I think, I hear a lot of people are using them, people are building instructional materials based on these recommendations, so I do think that they are getting traction and very useful, and I'll just sort of say the first one is systematic instruction. We called it systematic because people didn't like direct or explicit, because we had a diverse group of people on the panel, some people in math ed. So the idea is to provide intentional instruction during intervention to develop student understanding. Math language is so important to teach clear and concise math language and support students' use of the language to help students communicate. Representations, choose them very carefully, using a set of concrete and semi-concrete representations. Of course, the number line, we've kind of set that apart because it's been so important, not in terms of just fractions, but also teaching whole numbers. And then word problems, an area that's near and dear to Lynn's heart, to provide deliberate instruction in that area to deepen students' mathematical understanding. And then the final recommendation, which turned out to be kind of controversial because we said timed activities and fluency. We kind of just really meant fluency, but as you saw, Lynn's work did show that timed activities, if they're implemented appropriately, can be very helpful. But, some people just are adamantly against timed activities, so I think the idea in any case is to build fluency. So this is the components of our intervention that we tested with the 6th graders, with the teachers. We emphasize fractions as numbers with magnitudes, fraction equivalence and ordering, and fraction arithmetic. And in our developmental studies, it was really hard to move children on the fraction arithmetic. For whatever reason, we had a hard time getting effects in that area. But we did emphasize fractions as numbers, and the number line model really does transfer easily to linear measurement, which is often needed in everyday life. And it was so really amazing on some of the pretests how little the children knew about using rulers. And so, children, I guess, yeah, it's like, but it's just like such a useful skill for many vocations. So our instructional approach, we aim to make explicit, systematic math connections, and to make these connections explicit and to make learning stick, which I learned about that book from Bethany. It was like so great. We use multiple representations, gesturing, concreteness fading, retrieval practice, which we did. Marsha was talking about interleave practice. We incorporated that. And then, of course, we provided clear, immediate feedback. The study design was a multiple cohort, randomized controlled study with sixth graders, as I mentioned, very low in math. The level of randomization was at the classroom level, so it does require you to have a fairly large sample, and so we had 38 classrooms. Our goal was, I think, 48. We were underpowered because we intersected with the pandemic, and it was just so much harder to get into schools. And the teachers did carry out the intervention with professional development from the research team, and the teachers varied a lot in terms of their background. Some were math teachers, some were special ed teachers, some were science teachers. It's like, and there's a teacher shortage in Delaware, but we felt like we wanted to work with what we had, which was realistic in a school setting. We had 24 half-hour animated PowerPoint lessons. It wasn't a whole lot. The lessons, I think, were like about a half hour, but that's all we could work on into the school with their schedule and their marking periods. And we had a pre-test, post-test, delayed post-test design with various measures of fraction knowledge. We explicitly incorporated the principles that I mentioned. We anchored our instruction in meaningful contexts, which were centered on visual number lines and fraction bars, like we used color run races, things like that were very motivating to the children. And as I mentioned, number lines can map onto so many everyday activities, like even a measuring cup is like a vertical number line. We used the clear and consistent mathematical language. We said numerator and denominator rather than top number or bottom number. And we used familiar denominators to develop deep understanding and reduce cognitive load. I think this is super important because sometimes in math instruction, and for kids who are struggling, they move quickly to large denominators that you don't use that much in everyday life, and plus it's like hard to really think about the concepts. So with the familiar fractions like a half, 2/4, and so on, we can really focus on the meaning of fractions. And then we did engage in fluency with fractions and multiplicative reasoning. So in honor of Lynn, here's an example of a word problems activity that we incorporated into some of our instruction. And I hope the animation works. We like to show problems side by side to highlight differences in terms of what the problems are asking for. So the teacher would say, here are 3 story problems. Read them to yourself as I read them aloud. So Adrian walked 2 miles on Monday and 3/4 of a mile on Tuesday. How far did Adrian walk altogether? Then Adrian walked 2 days this week. He walked 3/4 of a mile each day. How far did Adrian walk altogether? Adrian walked 2 miles on Monday and 3/4 a mile on Tuesday. How much farther did he walk on Monday than on Tuesday? Now, those problems to students look very similar, and they might just read them all the same way. So we help students see that the first step to solving problems is to find the operation, but the story problems don't tell you the operation. You have to figure it out. So you need to look at 2 parts of the problem to find the operation of the action and the question. So we ask the students which 2 problems have the same action. So the first one and the second one, and we discussed that and talked about it. And which two problems have the same question? And so here, it's a little bit different. No two problems have the same action and the same question. Each problem is solved using a different operation. So we also need to find the numbers to use with the operations. So the children worked on that and circled the numbers. You can see they're all exactly the same. But so in terms of story problems, you have to find the action, the questions, write the operation with the numbers, model the action, and answer the questions. So we had lots of activities related to this. And so this would be something like Adrian walked 2 days this week, and that particular problem. And so the child would underline the action, circle the question, and then figure out the operation, which would be here. We are making two groups of 3/4. The operation then is multiplication. So they would go 2 times 3/4. And now that we have the operation and the numbers, we can model the action, which would be something like this. Sometimes multiplication is hard to represent on a number line, but on some of these simple problems, they could go like this. This is one group of 3/4. Writing a label will help you remember what you've drawn. So far, the label can be simple like this. Day 2, and they had number lines at their desk. And then they can answer the question, what does our model show? On the number line, it's easy to see the simplest form, which is 1 1/2. And so don't forget to write your answer in the box. So that's just kind of an example with very simple fractions and seemingly simple problems that children can learn to differentiate between problems and kind of what the meaning of multiplication of fractions is, and especially a fraction and a whole number, versus addition and subtraction. So our study, we finished it, and we were happy that we got significant and meaningful effects, given that the instruction was carried out by teachers with lots of noise, like we had teachers go on leave or even have substitute teachers some of the time, and intervention was often not considered a priority. So if there was an assembly, they would cancel intervention class, and all these kinds of things. But we got moderate effect sizes on the concepts, which is less well aligned to the intervention. The applied problems, we were very happy to get effects on fraction arithmetic, which we hadn't been able to move too much. Huge effects on measurement, just because the children started out so low, they knew very little. And we had a lot of activities related to measurement. And then also just by we had these like quick sprints where they just for I think a minute or two at the end of each lesson, they worked on they did time multiplication activities related with facts that were related to the problems they did. And we got pretty good effect sizes just by doing that. And I also think working with the fractions helped improve multiplicative fluency also, because they were kind of seeing the various connections. So, and then just quickly, one other thing is we have some new RCT work funded by NSF that continues to be very influenced by our fraction center findings. We just completed this particular grant, and then we have another one moving forward. But as I mentioned, our fraction center longitudinal data showed that students begin formal fraction instruction with varying levels of knowledge. Some are really, they know a lot, But others don't respond well to instruction at all. So that I teamed up with Nora Newcomb, who's a cognitive psychologist at Temple, and actually she was at one of our IES, she was a discussant at our IES center, at the end of the center where we presented at the Department of Education, so we got to talking and with one of our postdocs, and we really got interested in the roots of individual differences in fraction learning trajectories before formal instruction begins, to prepare children for the formal learning of fractions so they don't get to the place where they have a whole number bias, they don't expect fractions to make sense, because studies have shown that even young children have some informal knowledge of fractions. So in this study, we investigated the malleability of early fraction learning in first graders. We developed a series of play-based instructional activities to assess what extent structured training could effectively enhance young children's learning. And we had children from a wide sample of children, a number of them from fairly impoverished areas. They were high-risk students. And we did find that children who received the training demonstrated notably larger and meaningful gains on informal fraction knowledge. We developed an informal assessment. In that particular study, we weren't able to follow up the students, but we have a new study that we're going to follow up to see if these students, if the earlier you work on learning fractions and thinking about fraction magnitudes, that we can prepare students so they come to fourth grade, third grade with more knowledge, and we don't have these children in sixth grade who really don't even understand what a fraction is, or they don't understand that the numerator and the denominator have to work together. They're not separate numbers. So, in conclusion, Lynn has helped me think deeply about mathematical topics. We kind of got into the fractions at the same time. Also to use systematic evidence, as was mentioned by Elizabeth and others, evidence-informed intervention approaches to support children with math difficulties, and to bridge research and practice through effective implementation of RCTs in school studies, and to understand better how children learn and why so many children struggle and how to help them. So, thank you so much, Lynn, for your influence, for your kindness, and for your brilliance.